Okay, good evening. Welcome to the another session of Parabola. And in this session, we're going to see the reflection property of the parabola. The reflection property of parabola. No. So I'm going to assume a parabola. So assume the standard parabola just for the derivation. Of course, we can utilize this for other solving other problems. So assume the standard parabola y square is equal to 4ax. And I'll assume the point. Let p 80 square comma 280 be a point on the parabola. Be a point on the given parabola. Now, equation of tangent, we can get it. So the equation of tangent at point P, 80 square comma 280 is yt is equal to x plus 80 square. That means I have now a parabola and a point on it. We have written the equation of tangent at this point P, which turns out to be this. Now this tangent meets x-axis. We'll find the point of intersection where this tangent meets x-axis and y-axis both. So this tangent meets x-axis at, let us say R. Okay, so let this tangent meets x-axis at R and y-axis at, say, Q. So we can get the coordinates of R basically. So the coordinates of R is going to be, this means x-axis at R. That means if it is x-axis, then we can put y equal to 0. So R coordinates are going to be minus 80 square comma 0. And for Q, we can set x is equal to 0. So we get y is equal to 0 comma 80. So for the things which we have discussed, we can have a quick view. So I have this parabola and this is my point P, which is 80 square comma 280. And the tangent line meets the x-axis. That means the axis of parabola here at point R, which is minus 80 square comma 0. And this is the y-axis, also called as the tangent at the vertex, basically. And this is my point 0 comma 80. So we are ready with this. I'll name it. So this is my point Q. Now our goal is to get the length of all these segments SP, PM, MR, and SR. So this is my point K. Now let's find out the length. So length of SP is nothing but the focal distance of this point. So focal distance of point is nothing but A plus AT square. So we just need to add the abscissa. That's it. So SP is going to be A plus AT square. And now since SP is same as PM by the definition of parabola. So by the definition of parabola, I'm going to have length of PM also same, which is nothing but again A plus AT square. And length of, if I find SR, so length of SR is nothing but, this length is A up to this vertex. So vertex is O origin. So up to O, this is nothing but A. So this is A, and this right here is nothing but 8 plus 80 square. So I'm going to have again A plus 80 square. Now it remains to find out this MR length. So coordinates of M are nothing but x coordinate is minus A and y coordinate is 280. So therefore length of MR we can find out by using the distance formula. So MR is minus A plus 80 square, the whole square, plus 280 minus 0 square. So when I expand this, I'm going to have here A square minus 2A square T square plus A square T power 4 plus 4A square T square. I can open this to have A square, and 4 minus 2 is going to be plus 2A square T square plus A square T to the power 4, which I can write on the perfect square of A plus AT square the whole square. So this is nothing but A plus AT square. So we ended up proving that all these distances, SP, PM, MR and SR are equal. So this implies SP, PM, MR, and RS are equal. So basically, this is a quadrilateral and all these lengths are equal. So from this, we can conclude that RPSM, uh, RMPS, we should write better. So RMPS, so RMPS is a rhombus. So we know the property of rhombus, the diagonals of rhombus. So diagonals of rhombus are perpendicular bisectors of each other, are perpendicular bisectors of each other. And second is that they are interior angle bisectors. They are interior angle bisectors. Then is diagonal of force. So if I consider the same diagram, that means I can see here. So the diagonal here is basically one of this tangent. So this tangent PR is acting as the diagonal. And this will now bisect the interior angle. So I know that this angle is now going to be bisected. And also that they are the perpendicular bisectors of each other. So we will now find out the midpoint of SM. So midpoint of SM is going to be, so midpoint of SM we can find, this turns out to be, coordinates of M we can write down. It's again minus A comma 2AT. So if I find the midpoint, then it's going to be what? A minus A over 2 comma 2AT plus 0 over 2. So from here I get this is 0 comma 8T. So that means this Q is nothing but the midpoint of, so Q is the midpoint of SN. So Q is the midpoint of SN. So Q is the midpoint of SN. That means this diagonal, if I consider, and they are perpendicular here, that means this is 90 here. So this is 90 here, and Q is the midpoint of S and M. So if I consider my tangent, this PR is the tangent here, and if I see the image of S, so image of S, if I consider in the tangent, then it is nothing but lying on the directrix. It is lying on the directrix. So from this we can write down here, image of focus upon any tangent. Focus, image of focus upon any tangent to the parabola. Any tangent to the parabola lies on the directrix. It's on the directrix. So we know this improper. We know this important point about this reflection property now. That if I have the focus, and if I just take the image of this focus upon any tangent to the parabola, it will lie on the directrix. And now if I say this, so if I take this point to the point where it meets the tangent at the vertex, and if I have this angle, then this angle is definitely going to be the 90-degree here. So we can give one more conclusion. So we can give one more conclusion. So the conclusion will be the foot of perpendicular drawn from focus. So this will be called as the foot of perpendicular. So the foot of perpendicular drawn from the focus. So the foot of perpendicular. So the foot of perpendicular drawn from focus upon any tangent to the parabola. Any tangent to the parabola lies on the tangent at the vertex. Lies on the tangent at the vertex. Now, so it lies on the tangent at the vertex. And also S, Q, M are in the collinear. That means they are in the straight line. So now we can write down the reflection property. So what does the reflection property mean here? Okay, let's write it down. So if I consider the reflection property, for the reflection property, I'm going to have, let's say, imagine this red line. Okay, so this red line I'll be completing now. So imagine this red line. Let us say it is being incident from this interior part. So suppose this is my incident line and it is incoming here. Then it gets reflected by the parabola from after reaching this point, and then it will pass through the focus. So it will pass through the focus. So that means if I take any point here again, say if I again have a line here, then it will meet at this point. Now after meeting it will again pass through the focus. It will again pass through the focus. So it will happen exactly like this. So again here, it will again pass through the focus. Again, it will be incident here. It will again hit the parabola and pass through the focus. Again, pass through the focus. Pass through the focus. So this is what the property states. So we can now write down this property. So the array incoming parallel to the array incoming parallel to the axis of parabola. So array incoming parallel to the axis of parabola meets the parabola and gets reflected. And the and the reflected ray passes through the focus of parabola. Passes through the focus of parabola. And this is what we have to prove. And this is what our reflection property of parabola is. So now, for this, if I have to design a question, like let's say what kind of things we can apply, what kind of things we can solve using this property. So for this thing, I'll just consider, let's say, a random problem. So this is not a planned thing. You can now imagine. So I'm going to draw a parabola. This question we're just taking randomly. So say let us say I have a point P here. Okay, you can take any point. Say I'll be just taking the equation of tangent at this point instead. So let equation of tangent at this point. Suppose I'm taking, say, just for simplicity we can take it. So x plus y minus 2 is equal to 0. Suppose this is my tangent at the point P. So of course we now have to write down the coordinates of the point P, which are on the parabola. So we can just take any point which lies on this line, and we can make it a point on the parabola. So for this, we can simply take, let's take here 1 plus 1 is 2 and 2 0. So yeah, I can take 1 comma 1. So let P be any point, and the equation of tangent to the equation of tangent is given at the point P is x plus y minus 2. And now imagine that someone is asking me uh, to find the equation of directrix or the length of lattice rectum or anything about the parabola. We can get it. I have to also give the focus because that's what important part is. So the focus we can give, say any focus if you want. Okay. So let's take minus 1 comma minus 1 just for simplicity. So now the question would be, so find the directrix, and the length of lattice rectum and the length of lattice rectum of the parabola having focus at minus 1 comma 1 and tangent at point P 1 comma 1 on the parabola is x plus y minus 2 is equal to 0. Let us say this is a designed question. It's completely right in front of you, as you can see. Now, let's have a look. How do we approach this problem? By using the reflection property, we can solve this. In fact, you can draw n number of problems. You can solve, in fact, n number of problems using this concept. So what I'm going to draw is, I have this focus minus 1 comma minus 1. So now I'm going to find the image of this, because if we look at this diagram, so first we should be sure how are we going to implement. So I'll explain the idea. So imagine I don't care about the shape of the parabola. We're not interested and we don't know even what kind of shape we're going to have. So instead, what we will do, just assume it, okay, that it's a simple diagram. This is my parabola. And here I have the focus, which is minus 1 comma minus 1. And I have the tangent at the vertex. So tangent at point P. So this is my point. Now what I'll be finding the image of this minus 1 comma minus 1, image of this focus in this tangent. So I know this is going to be my point M. So this point M is going to definitely lie on the directrix. So this is going to lie on the directrix. So once I got the image, basically, once I got the image, so I am done. Because I know that that ray which is going to be incident here, okay, this. So this ray will definitely meet at this point. And I know that this is going to be what? This PM, okay. PM is definitely going to be perpendicular because that's perpendicular distance. So PM slope I'll be having, and I have the point M. I'll have the slope of this directrix. I can get the equation of directrix. Once we got the directrix, and then by again using focus directrix property, we can get the equation of parabola. And once you got the parabola, you can get everything, whatever you want. Then let's go ahead. So let's find the image of focus. So let's find the image of focus in x plus y minus 2 is equal to 0. So assume the image is h comma k, and now you can find out. So h minus 1 means h plus 1 over 1 is equal to k plus 1 over 1 again is equal to minus 2 times. We can plug in here minus 1 minus 2 over 1 square plus 1 square is second 2. So this 2 and 2 gets cancelled, and I'm going to have h plus 1 is equal to k plus 1 is equal to, this is going to be 4 here. So from here I can get h is equal to 3 and k is also got 3. So I got the image to be 3 comma 3. So m is going to be my 3 comma 3. Now I have my point P. Point P is given to be 1 comma 1. So we can now get the slope of PM. So therefore, slope of PM would be 3 minus 1 over 3 minus 1, which turns out to be 1. So therefore, the slope of this line is going to be minus 1. Okay. So therefore, the slope of the directrix. So slope of the directrix would be minus 1 because it's going to be perpendicular. So equation of directrix can be obtained by, so equation of directrix, we can get it by the slope point form. So equation of directrix can be obtained by slope point form. Can be obtained by slope point form. Now imagine, so y, the point is 3 comma 3, of course. So y minus 3 is equal to minus 1 into x minus 1. So it's going to be x plus 3. No, it's 3 comma 3 only. So we'll write down here minus 3. So that means I now have y minus 3 is equal to minus x plus 3. So I can get it x plus y minus 6 is equal to 0. So this is the equation of the directrix. To find the length of lattice rectum? No. So for the length of lattice rectum. Now imagine. For the length of radius rectum, what do we do? Since we don't have the tangent at the vertex, otherwise we would just have found this distance and multiplied by 4. So now what we will do? Now we know that this distance and this distance both are equal. So rather I'll find out the distance of this point S from the directrix. That means I have this parabola. So this is my directrix. This is my tangent at the vertex. And this is the focus. And length of lattice rectum is going to be, of course, this. This is going to be 4A. So this is my point A. So this is also A. That means if I find out this distance, I already have 2A. So minus 1 comma minus 1 to this line, which is x plus y minus 6 is equal to 0. This is the directrix. So if I find this distance, it is going to be, so d is equal to 2A. So length of lattice rectum is going to be 2D, which is what? 2 times 2A, which is 4A. So that means it is now enough to find out the length d. So d is basically distance of the point. This is my point minus 1 comma minus 1, and here I have the line x plus y minus 6 is equal to 0. So please calculate. So d will be minus 1 minus 6 over square root of 1 square plus 1 square. So this is my distance. So this turns out to be 61718. So 8 over root 2. So therefore, length of lattice rectum would be, so length of lattice rectum would be 8 over root 2 multiplied by 2. Okay, it's just double. So it's going to be what? 16 over root 2. Or you could add 8 root 2. So we found the length of lattice rectum, okay, by using this property simply. Now, look at this question. Okay, so the beauty of this question lies in the reflection property. So I've taken this question from one of the standard references. So I'm going to solve this by using reflection property. So if 3x plus y minus 3 is equal to 0 is tangent at the vertex of a parabola. So you imagine that this is the parabola. Of course, not standard because we do not know what is this parabola. So I'm just assuming that this is the tangent at the vertex here. So x plus y minus 7 and 2x plus y minus 3 are other two tangents to the same parabola. Then find the focus. So if I just have another parabola and I take this parabola, or its tangents basically. So I know that this tangent will meet at this point. Wait a moment. I'll draw a diagram because it's not indicating the clear message. Um, Consider this to be the parabola. Now, if I have a tangent here, say x plus y is equal to 7, and the other tangent is 2x plus y minus 3, it might be somewhere. Let's take it here, suppose. Now, this is the foci, suppose, which we do not know S. But we know that from this property, so the property that we have derived is this one, that image of focus. So this one won't work because we don't have it's not required. This property we can use. The foot of perpendicular drawn from focus upon any tangent to the parabola lies on the tangent at the vertex. This is a very important property. So that means the foot of perpendicular drawn from foci. So if I have this foci, if I draw the foot of perpendicular, then of course it will lie on the tangent at the vertex. So this is going to be perpendicular here. And also the same story will happen here. My God, what is this? So the same thing would happen here also. So if I just draw it perpendicular right here. So say this is my point M, and so this is my point N. So which means I need to find out the focus. So for this thing, I can find out this is my tangent at the vertex, which is 3x plus y minus 3 is equal to 0. And this is my line x plus y minus 7 equal to 0. And the other line is 2x plus y minus 3 is equal to 0. Now I want the focus. So what I'll do, I'll solve these two equations simultaneously and get the point M. So once I've got the M point, now I know the this line. Okay, so I can get the equation of line ms because that is going to be perpendicular to this line, this tangent, and also I can do the same stunt with this. I can find the equation of Sn, which is perpendicular to this tangent. So once I got these two equations, solving these two equations simultaneously would give me my point S. That is the point of intersection, which is nothing but the focus. So if I have line x plus y is equal to 7 and 3x plus y is equal to 3, I can simply subtract. So 3 minus 1 is 2 is equal to minus 4. That means x is equal to minus 2. So if I can plug in here x is equal to minus 2, so y is going to be 9. So this point M is nothing but minus 2 comma 9. So I've solved for these two point of intersection. I'll also solve this line. So x plus, no, not this, 3x plus y. So 3x plus y is equal to 3. And the other line is 2x plus y is equal to 3. So I can solve them together. So I directly get x is equal to 0. And if I put x is equal to 0, I get y is equal to 3. So point n is 0 comma 3. So this is my tangent 1, and this tangent 1 I've taken x plus y minus 7, and tangent 2 is this one, tangent 2. So slope of tangent 1 is basically what? Minus 1. So therefore, slope of ms would be 1. So equation of ms. So I found the point m, which is minus 2 comma 9, and slope is this. So I get the equation of ms, which is y minus 9 is equal to x plus 2. This means I get x minus y minus 11 is equal to 0. This is my one of the line. X minus y minus 11 is equal to 0. X minus y, yeah. Equation of ms we have found. Now let's also find equation of ns. So equation of ns I'll find out. So for this I need the slope of the second line. Slope of tangent 2. Slope of tangent 2 is minus 2. So therefore slope of ns would be 1 upon 2. So therefore equation of ns would be y minus y1 is equal to m into x minus x1. So this gets cancelled. I get here 2y minus 6 is equal to x. And now solving this line with this line would give me the required equation, required point of intersection basically. So let's solve them together. Yeah, this one is plus. So let's go ahead and solve these two. So solving x minus y plus 11 is equal to 0. And the other line is 2y minus x is equal to 6. That means x minus 2y. So x minus 2y, and this is going to be minus 6. So x minus 2y is equal to minus 6. So plus 6 is equal to 0. So we can solve these two together. So of course I can simply subtract and I get y is equal to 6 minus 5, 11. So y is equal to minus 5. And when y is minus 5, I get x is equal to 5 plus 11, 16. So it's going to be minus 16. So therefore, the focus of the parabola is minus 16 comma minus 5. So we used the reflection property to find the focus. Okay. Thanks. We'll see you in the next video.